To protect yourself and others, you need to have basic knowledge of pesticide hazards and first aid. This module will help you know the different types of effects pesticides can have on your health. We'll review the importance of signal words and how you can be exposed to pesticides. You will also need to be able to recognize some common symptoms of exposure and know when and how to give first aid. Although humans, insects, and rodents are very different from one another in some ways, they're very similar. All these animals have similar nervous systems, circulatory systems, and respiratory systems. So a pesticide designed to attack an insect's nervous system could attack a human's nervous system in the same manner. In humans, pesticides can cause both short and long-term health effects. And don't forget about the physical and chemical risk pesticides pose. Some are explosive, flammable, or combustible. What's the hazard or risk of a particular pesticide? In order to determine the hazard of any pesticide, you must know two things: product toxicity and human exposure. Toxicity is the capacity of a pesticide to cause injury, either short or long term. Toxicity is a property of the pesticide itself. Exposure is what happens when the pesticide comes into contact with the human body. How a pesticide is formulated can increase or decrease the risk of exposure, which in turn changes the hazard. The fundamental principle of risk management is understanding product toxicity and applicator exposure. To reduce risk, you either select a lower toxicity product or reduce your exposure. In order to assess your risk when handling pesticides, it's critical that you understand both toxicity and how you can be exposed. Let's look at each of these factors. Let's take a look at two common products and assess their hazard. Gasoline is extremely toxic to humans if swallowed or inhaled. However, gasoline pumps have been designed to eliminate or greatly reduce the chance of human exposure. So, the hazard of filling your car's gas tank is very low. Aspirin is another common product that can be hazardous. The toxicity to humans is low, but the potential for exposure is high. For example, if a child were to swallow an entire bottle of aspirin, they would become very ill. In this case, the hazard of children swallowing large amounts of aspirin is high, and that's why we keep medicines out of reach of children by using engineering controls like child-resistant lids. Hazards increase when you're mixing and loading. The activity of mixing and loading generally has a higher hazard than applying a pesticide because you're exposed to the chemical in its most concentrated form. It hasn't been diluted yet. During the pesticide application, your risk is typically lowered since the chemical has been diluted. This doesn't mean that the hazard during any application is nothing to worry about. Your hazard can be substantial. Harmful effects can occur from a single exposure or many small exposures over time. Always follow label directions and safety precautions. To minimize the hazards associated with pesticides, there are two things to do. Use the least toxic product or wear personal protective equipment. You must have a good attitude and have respect for the products you're using. This means reading and following the label directions. Not only is the label the law, but the information found on it helps protect you and the environment. You have a responsibility as a certified pesticide applicator to use and handle the material in a safe manner and according to label directions. Other than looking out for yourself, you must be aware of your surroundings. Look around and see if there are unprotected people, animals, or sensitive areas near or in the application site. Accidents do happen. By taking adequate precautions, you reduce the likelihood of having a pesticide use accident. Any chemical can be harmful, but the risk of a pesticide or chemical illness depends on the dose and route of exposure. The effects of a pesticide poisoning may be contact effects, systemic effects, or allergic effects. Contact injury occurs when the human body comes into contact with a pesticide or chemical. When your skin is exposed to a pesticide, the area exposed is affected. Skin effects include irritation, itching, redness, rashes, even blisters and burns. Eyes may become irritated and may have swelling, stinging, and burning. Irritation can occur in your nose, mouth, or throat. Many herbicides and fungicides cause contact injury in the form of dermatitis or skin irritation. Contact injury to the skin is the most common form of pesticide poisoning. This makes good sense since most applicators handle only herbicides and may not protect their skin or eyes as well as they should. Systemic effects occur mainly from exposure to insecticides, rodenticides, or other pesticides that target animals. An insect's nervous system and a rodent's circulatory system are similar to ours. Therefore, when we're exposed to an insecticide or rodenticide, they act against our systems the same way. It's simply a matter of dose. Paraquat is one unique herbicide that can cause death in humans. Some common symptoms of a systemic insecticide poisoning are nausea, vomiting, headache, dizziness, chills, thirst, and difficulty breathing. The third type of effect is an allergic effect. Allergic reaction may occur as either contact or systemic reactions, and allergies vary from person to person. Allergic effects include dermatitis, blisters, red or itchy eyes, asthma, and life-threatening shock. It would be great if there was an easy way to tell if a person was allergic to a particular pesticide, but unfortunately, there's not. Okay, we've discussed the three types of effects on the human body from a pesticide poisoning, so now we'd better talk about how a pesticide enters the body, or the routes of entry. There are four main routes of entry. The first and primary route of entry is the skin. Studies show 97% of all pesticide exposures during the pesticide application are by skin contact, or the dermal route of entry. Take a look at the picture on the left side of the screen. This person was mixing, loading, and spraying without wearing gloves. There is a fluorescent dye in the product added to the tank mix to illustrate exposure. Under normal light conditions, their hands look clean and uncontaminated. However, if we take a look at the same hands at the right under the black light, we can see how much pesticide is really on their hands. If this person had worn a pair of gloves, they would greatly reduce their exposure, which reduces their hazard. Remember, hazard depends on toxicity and exposure. This graphic helps illustrate the ability of different parts of the body to absorb pesticides. Parathion was placed on the skin for 24 hours and the dose absorbed was measured. Boy, there are some sensitive areas that readily absorb while others are more protective. The scalp and forehead absorbed 32 and 36% of the exposed parathion, while the palm of the hand was only 12%. Pesticides are easily and quickly absorbed in warm, moist areas, including the groin. Ladies and gentlemen, don't forget to wash your hands before as well as after going to the restroom. Open wounds, abrasions, and rashes offer a more direct route of entry through the skin and increased dermal absorption of pesticides. The pesticide formulation itself influences how easily it's absorbed through the skin. If you think about it, how in the world could a granule remain on your skin long enough to have absorption occur? Dust and powders can get on your skin, but would not be actively absorbed unless they remained for some time. Now, an emulsifiable concentrate that has the active ingredient dissolved in an oil-based or petroleum solvent readily penetrates skin and carries the active ingredient into the body. The next route of entry is the lungs, or by inhalation. Certain pesticide formulations that easily become airborne increase the risk of inhalation injury. Wettable powders and dust are a concern when measuring and mixing because the light, airy dust particles can become airborne. Gases and vapors are an obvious concern, but even fine sprays from an application can be inhaled. An inhalation exposure can occur at any point in the application process, including mixing and loading, the application, or when applying in a confined space. Once the pesticide enters the respiratory system, it's easily and quickly moved throughout the body in the blood and can result in systemic illness or contact irritation. In situations where inhalation is a concern, wear a proper respirator and make sure it fits correctly. If a respirator does not fit properly, it does not provide protection. Solids or liquids that change into gases are called fumigants. Check the label before using any fumigant. Respiratory protection and post-application ventilation is usually required. Fumigants are non-selective. We call them biocides since they kill just about anything, and you don't want that to include you. Another route of entry is the eyes. Although eyes are small, especially when compared to the volume of skin, they can absorb a large amount of chemical and very quickly. Eyes may also be very sensitive to certain pesticides. Some pesticides, when absorbed by the eyes, can be corrosive and cause irreversible damage. Pesticides can get into your eyes by airborne dust, particles, or sprays, by splashing directly into the eye, or by rubbing your eyes with contaminated hands, gloves, or clothing. This is one good reason to wear eye protection even when doing routine maintenance on application equipment. Be aware your actions reduce the potential pesticide exposure. And the final route of entry is oral or by the mouth. The easiest way to reduce oral pesticide exposure? Yep, you guessed it. Wash your hands. Contaminated hands are a real culprit. Oral exposure can also occur when splashing pesticides when mixing and loading. Wearing a face shield during mixing and loading can help reduce oral exposure from splashing. Oral exposure also occurs when pesticides are improperly stored in household containers such as soda bottles, milk jugs, and quart jars. Practicing good personal hygiene and wearing the correct personal protective equipment helps avoid pesticide exposure by any route of entry: skin, lungs, eyes, or mouth. If there's a pesticide exposure, there are some possible harmful effects. These effects are classified as acute effects, chronic effects, or delayed effects. Acute effects are those that occur after a single exposure and develop within 24 hours of the exposure. The effects can be systemic, contact, or both. Acute toxicity effects are determined by exposing laboratory animals to the toxicant. EPA requires testing of acute systemic effects by measuring any negative effect that occurs through doses that cause death. When comparing toxicities of pesticides and classifying pesticide toxicity, scientists and EPA use an LD50 or LC50 measurement. Let's take a look at what that means. LD50 and LC50 are laboratory experiments that measure the dose it takes to kill 50% of the test animals. For example purposes, let's say we have 3 populations of laboratory rats. Through oral exposure, we feed 100 rats each a particular dose of the toxicant, and we have 3 different groups. One group gets 100 milligrams per kilogram, another 10 milligrams per kilogram, and the last group 1 milligram per kilogram. After 24 hours, the test rats are evaluated for any negative effect and the dead rats are counted. The group of rats that has 50% of its group living and 50% dead was fed the lethal dose 50. So this dose, 10 milligrams per kilogram in this example, is the LD50 for that chemical. These studies are performed for skin and oral exposures and stated in LD50, lethal dose 50. Inhalation is measured by putting a concentration in the air or water, so the measure is the LC50 or lethal concentration for 50% of the test animals. Eye toxicity studies are done as well. So the scientists actually have a number for known dose for the LD50. The lower the LD50 value, the more toxic the product. You don't find the LD50 on the label, but EPA sets the signal word based on LD50 values. When setting the signal word, in addition to the LD50 value, EPA uses other effects, like skin or eye damage or irritation. Toxicity measures are used in different ways, but they're all based on the same principle. We can talk about the general toxicity of a product as being highly, moderately, or slightly toxic. We can classify a product as a Category 1, Category 2, or Category 3 toxin, or we can talk about the LD50 value. You must memorize the different classifications and levels of toxicity assigned to different signal words. So let's go through an exercise with a product whose oral LD50 value is 35 milligrams per kilogram. What signal word would it have? 35 falls between 0 and 50, so it's a Category 1 hazard, highly toxic, and carries the danger, poison, peligro signal word with skull and crossbones symbol. Now, if you had a Category 2 hazard, what signal word would it carry on the label? Warning, and it would be moderately toxic. The concern may be either an LD50 between 50 and 500, or it could be from the concern for eye and skin injury. Find this chart in your study material and spend some time learning it. I hope you can see that the smaller the LD50, the more toxic the chemical, and the less it takes to kill 50% of the test population. Highly toxic refers to about a pinch or less of material. Let's review the 4 signal words in order from the most to least toxic. The highly toxic products have the signal word danger, poison, peligro with the skull and crossbones. Peligro is Spanish for danger. You'll find most signal words in both English and Spanish on the pesticide label. Danger poison indicates that products are highly toxic by any route of entry. The LD50's values of a pesticide with the signal word danger, poison, peligro with the skull and crossbone would be very small. It only took a little bit to kill 50% of the laboratory test population. It's usually very easy to find the signal word on a pesticide label. Here's an example of a label with danger, poison, peligro, and the skull and crossbones. If you are using a pesticide with this signal word, remember that it's highly toxic no matter how you are exposed to it. The signal word danger, peligro alone, without the word poison and a symbol of the skull and crossbones, has a very different meaning. Though the product is still highly toxic in very small doses, it is still a Category 1 hazard. This signal word tells you, the pesticide user, that the product is corrosive and may cause severe eye damage or skin irritation. The routes of exposure that are of greatest concern when using a pesticide with the signal word danger, peligro, are eyes and skin, and not oral and inhalation. The signal word can be found at 2 places on the label. Here you can see it below the statement, keep out of reach of children, and under precautionary statements. Looking under the signal word, you can see that the first word is corrosive. Knowing what the signal word means helps you to protect yourself. This example, danger, means causes irreversible eye damage. So if you were handling this product, you'd want to make sure you're wearing appropriate safety goggles. A pesticide with the signal word warning, aviso, is moderately toxic by any route of entry. A pesticide label has the signal word warning, aviso, when the LD50 is between 50 and 500 milligrams per kilogram. What this means in units that are a little easier to understand is that 1 teaspoon to 2 tablespoons can be fatal to a 150-pound person. Also, as shown in this example, the concern is for moderate eye damage and skin irritation, not the LD50. With warning, it is important to read the precautionary statements to identify the concerns. Take a look at this label for Roundup Original. The signal word is warning. If you look closely at the label, you can see that this product can cause temporary eye injury. Remember, products with the signal word warning are moderately toxic by any route of entry. And the last signal word is caution. Products with this signal word are slightly toxic by any route of entry. The acute oral LD50 values for a product with the signal word caution are large, between 50 and 5,000 milligrams per kilogram, or you would need to be exposed to a lot before significant injury or death could result. Again, the caution may be due to skin or eye injury. Here is an example of a fungicide label with the signal word caution. There are still precautionary statements that need to be followed, and misuse can result in damage if swallowed or if it gets into eyes and onto skin. Pesticide warning statements are not unique. Many everyday products such as gasoline have warning statements and signal words. Remember, hazard is dependent on exposure and toxicity. The only reason the gasoline is low hazard is because of your low exposure. If you're handling it in a plastic container, the hazard increases significantly. LD50s are not always the best measure to use when discussing toxicity, since they don't give you all of the information about a pesticide's hazard. They tell you what amount of the chemical causes death, but not about other less serious acute effects. Because the LD50 studies are conducted on laboratory animals, such as mice and rabbits, the numbers cannot be applied directly to humans. Some products like Paraquat, a danger poison herbicide, are actually more toxic to humans. LD50s also only account for a single exposure. Okay, we just discussed acute toxicity from single exposures. Let's define chronic effects. Chronic effects occur after many low-dose exposures over a period of time like years and years. EPA requires manufacturers to conduct chronic toxicity studies and evaluate products for many chronic effects like birth defects, fetal toxicity, tumor development, genetic mutations, blood or nerve disorders, and reproductive effects. If a product shows chronic effects, the label lists the concern. The material safety data sheet will also discuss potential chronic effects. Delayed effects from a pesticide exposure may develop more than 24 hours later, sometimes as a result of repeated exposure. Organophosphate and carbamate insecticides have been known to cause symptoms such as memory loss after repeated exposure to these neurotoxins. Now, I realize many of you may never handle insecticides, but we still need to be aware of how two classes of insecticides work to harm us. Many people perceive all pesticides to cause harm in this way. How do organophosphate and carbamate insecticides work? They affect the nervous system by inhibiting cholinesterase, which is a critical nerve enzyme that moderates the nervous system. Cholinesterase in your body acts as an off switch after a nerve has been stimulated and sent its message. It allows nerves, muscles, glands, and organs to go back to a resting state. When people are exposed to organophosphate or carbamate insecticides, these insecticides inhibit cholinesterase, the off switch, and nerves then continuously fire, overstimulating muscles, glands, and organs. Overstimulation results in the body wearing out and shutting down. You may be familiar with some of these active ingredients or products that are classified as organophosphate insecticides: diazinon, chlorpyrifos, orthene, malathion, and metacystoxar. Some carbamate insecticides you might know are carbaryl, methomyl, aldicarb, and carbofuran. Symptoms from organophosphate or carbamate insecticide exposure depend on how much exposure occurs. The dose makes the poison. If someone is mildly exposed, they could experience fatigue, headache, giddiness, sweating, dizziness or blurred vision, cramps, nausea, vomiting, or diarrhea. A moderate exposure could cause numbness, changes in heart rate, general muscle weakness, difficulty breathing and walking, pinpoint pupils, or excessive salivation. If a severe exposure occurs, the victim could go into convulsions or even a coma. Unfortunately, many of these symptoms are similar to heat stress symptoms. There are antidotes available for organophosphate or carbamate insecticide poisonings. For organophosphate poisonings, physicians administer atropine sulfate and protoplam chloride, or 2-PAM. For carbamate insecticides, atropine sulfate is used alone. The only other antidote on the market is vitamin K1 for certain rodenticide poisonings. There are no antidotes for paraquat or any other herbicide or fungicide. If you're working with organophosphate or carbamate insecticides, you should have your cholinesterase level checked. You should be tested prior to using these insecticides to establish your cholinesterase baseline. Each person has their own normal cholinesterase level. Then, when you start working with these insecticides, your cholinesterase level should be regularly monitored to make certain that you're not being overexposed. A few states have requirements for cholinesterase monitoring. It's important to become familiar with pesticide exposure symptoms. The symptoms that result from pesticide exposure vary according to the chemical and the person's body chemistry. Pesticide exposure symptoms can be very difficult, if not impossible, to diagnose. For example, if you have a headache and become nauseous when working with herbicides or even an insecticide, does it mean that you've been exposed, or are you getting the flu? It's good to be cautious. If you're working with a pesticide and then get a headache and become nauseous, it's wise to seek medical attention. Educate your physician about what you do and what products you handle so they can read up and be prepared to assist you. Which of these symptoms is the most common? I trust you know it was rash, since most exposures are to the skin and most people handle only herbicides. That's not to say some people don't get headache symptoms from herbicides, but skin reactions are the most common. Know your basic first aid for pesticide exposure. The basic rule to remember is dilute the pesticide. So, if you get pesticide on the skin, remove the contaminated clothing, wash the skin with lukewarm water. Don't use hot water or scrub the skin, since this can cause the pores to open and breaks in the skin. Did you know you should wash your hands for at least 10 seconds or as long enough to sing happy birthday? If pesticides get into the eyes, use clean water or an eye wash. Wash across the eyes for 15 minutes. That will seem like forever, but eye damage occurs quickly. Keep decontamination supplies handy near the pesticide storage area, mixing and loading area, and when you're applying. If someone inhales a pesticide in a closed environment, like a greenhouse, get the victim to fresh air. Also, have them lie down. If a pesticide is ingested, sometimes vomiting should be induced and the victim given activated charcoal. The label may suggest drinking water or milk to dilute the pesticides. There are times when vomiting causes much more harm than good. Also, recent studies have shown that syrup or Ipecac is ineffective. Be familiar with the first aid statements prior to finding someone in trouble. Vomiting should not be induced if the victim is unconscious or convulsing, since they could choke on the vomit. Never induce vomiting if the product contains petroleum products such as kerosene, gasoline, or oil. Emulsifiable concentrates contain petroleum solvents. If vomited, the solvents could be aspirated into the lungs. When corrosive poisons, strong acids, or bases are ingested, more damage can occur as they come back up if the victim is made to vomit. Know your products. When someone is exposed to a pesticide, take them to a doctor. Make sure to take the label with you so the doctor has all the treatment information. Be prepared for an emergency. Keep extra copies of the labels and MSDSs in your vehicle and office. Emergency numbers should be posted in several locations. Make sure to have the National Poison Control Center toll-free number in an obvious place where pesticides are stored, mixed, and in your service truck. The National Pesticide Information Center, NPIC, is another good resource for pesticide exposure information. I mentioned heat stress earlier when talking about insecticide symptoms, since most symptoms are similar. Heat stress can occur while working outside on a hot day, especially when wearing PPE. With heat stress, your body has run out of water. Heat stress can make you tired and dizzy. The skin can become clammy or hot and dry. Sometimes you may get a headache or become nauseous. You may be either chilled, sweat a lot, or not at all. If you think you may be experiencing heat stress, stop working, drink water, and cool down. Develop good health habits. Be cautious when working with pesticides to minimize exposure risk. Make regular exercise and a healthy diet part of your lifestyle. Keep hydrated. Drink lots of water. Wash your hands and face regularly. Shower regularly. Don't store or eat food near pesticides, including application equipment. In summary, the hazard of any pesticide is dependent on two things: toxicity and exposure. When exposed to a significant dose, a pesticide can cause contact, systemic, or allergic effects. Pesticides can enter the body through the skin, eyes, mouth, or lungs. To reduce the hazards when working with pesticides, use least toxic products and protect yourself with PPE. Become familiar with the acute and chronic effects for the pesticides that you're handling. Know first aid procedures in case a pesticide exposure occurs. Question 1. The ability of a pesticide to cause harm from extended exposures to low doses years later is termed A. Acute toxicity, B. Behavioral toxicity, C. Chronic toxicity, D. Lactic toxicity. The correct answer is C. Chronic toxicity. Acute means a one-time exposure. Question 2. Hazard is the measure of 1. Cholinesterase levels, 2. LD50 and LC50 values, 3. Oral, skin, eye, and inhalation exposure, 4. The capacity of a pesticide to cause injury. Choice A, 1 and 2 only. Choice B, 1 and 3 only. Choice C, 1 and 4 only. Choice D, 2 and 3 only. The correct answer is D, 2 and 3 only. Hazard is a function of toxicity and exposure. LD50 is a common measure of acute toxicity, and oral, skin, eye, and inhalation are the roots of exposure. Question 3. The most common way pesticides enter the body is by A. Eyes, B. Lungs, C. Mouth, D. Skin. The correct answer is D. Skin. Skin has more surface area to become exposed. This presentation was authored by Becky Hines, Carrie Foss, Carol Ramsey, and Brett Johnson of Washington State University Urban IPM and Pesticide Safety Education Program. In addition to sources noted on the image, graphics were provided by the following sources: Nevada Department of Agriculture, University of Missouri-Lincoln, Virginia Tech, Washington Department of Agriculture, and Washington State University. The presentation material was reviewed by Ed Crow, Maryland Department of Agriculture, Gina Kasai, U.S. EPA, Beth Long, University of Tennessee, and Susan Whitney King, University of Delaware. Narration was provided by Becky Hines, Washington State University Urban IPM and Pesticide Safety Education Program.